Good morning and welcome to my channel. If you're a returning subscriber, thank you for returning back to my channel. And if today is your first time visiting my channel, please click on the subscription button and also hit the notification icon so that anytime there is a new video and tutorial, you'll be the first to get notified. So to begin with, today we are looking at the tag 0x13C more singly linked lists. Last week we looked at singly linked lists. So today we are looking at more singly linked lists. So these are the resources that we are supposed to read or watch. So you can do your research on Google, and also you can also go to YouTube. So this particular video will be on YouTube for you to go and also have an in-depth knowledge concerning our singly linked list. Now these are our learning objectives. At the end of this project, you are expected to be able to explain to anyone without the help of Google. Then the general things that we are supposed to know is you'll be able to know how to use linked list and also start to look for the right source of information without too much help. Now somebody will say, okay, so if I watch your video, that means I'll be doing copy work. No, that is not the issue. Okay, my videos are supposed to guide you. Now if you are having issues with the script, you look at my script and you also come out with a new ways to write yours. Or if you want to make use of the script that I write, then you can change the variables. Okay, so if let's say my variable is, let's say, int a, okay, you can make yours int b. In this way it is not a copy work or plagiarism, because your work will definitely be different from my work. So the allowed editors are, we have the VI, the Vim and Emacs. All your files will be compiled on Ubuntu 20.04 LTS using GCC using these options. Then all your files should end with a new line. Now, as we always say, a README file is mandatory at the root of the folder of the project. And also your code should use the Betty star because it will be checked using Betty star. We are not allowed to use global variables, and also you shouldn't have more than 5 functions per file. The only 6 standard library functions allowed are the malloc, free, and exit. Any use of the functions like printf, put, calloc, realloc, etc. is forbidden. We are also allowed to use the function putchar. We don't have to push our putchar.c because they will use their putchar.c for us. So the prototype of all your functions and the prototype of the function putchar should be included in your header file called lists.h. And also we are not, or don't forget to push your header file. And also all your header files should be include guarded. Now before we move on, this is the data structure that we are making use of for this project. So before we start this particular task, which is tag 0, the first thing that we are supposed to do is to create our lists.h. But before you do this, we have to first of all launch our sandbox. After launching your sandbox, you change directory to the root of your sandbox. Then over here we can ls to be sure we are inside the root of our sandbox. So over here you can see that we are inside the root of the sandbox. So the next thing that we are supposed to do is to enter our ALS low level programming repository. So to do that, we type cd ALS low level programming. Then you hit enter. So right now when we list the content of this repository or directory, you can see that these are the previous projects that we have done so far. So today's project is 0x more singly linked list. So for us to be able to create this directory, you come over here, copy the name of the directory over here. Come back to your terminal and type mkdir command, that is make directory command. Hit space on your keyboard and paste the name of the folder or directory and hit enter. So right now when we ls, you can see that we now have our newly created directory. So it is inside this particular directory that will be performing or will be doing our project. So for us to navigate into this directory, we type cd 0x13, then you hit enter. Then over here you can ls to see whether you have anything inside. So because we only created an empty directory, you can see that there is no file over here. So the next thing that we are supposed to do, okay, when you come here, we are being told that a readme file at the root of the folder of the project is mandatory. So the next thing for us to do is to create our readme file. To do that, come back to your terminal and type vi space and you type readme.md. The .md is the extension for Markdown. Then you hit enter. In the command mode, hit I on your keyboard. Then you can now type your code. So to do that, I'll come here, copy this file, this name or the heading, come back to my terminal and paste. Hit enter. Come back here and also I'll copy my requirements over here just to make my readme long. Then I'll paste it over here. When you are done, hit escape on your keyboard and you type :WQ and you hit enter. Now the W is for saving and the Q is for quitting and returning back to this particular screen. So now let's check whether we have created our readme. So to do that, you list the content of the directory. So you type ls and hit enter. So you can see that we now have our readme file over here. The next thing that we are supposed to do is to now push this to GitHub. So to do that, we do git add git commit created readme file, then git push to GitHub. After a successful push, we can now continue with the rest of the tasks. So the next thing that we are going to create, or the next file that we are going to create, is our list.h. So to do that, copy the list.h name over here. Come back to your terminal and type vi list.h and hit enter. In the command mode, hit I on the keyboard to enter the insertion mode, then we type our code. So over here, we are going to first of all define our. So to do that, you type hashtag if ndef, then list underscore h. Then we can now define then list underscore h. So we can now import our standard definition. So hashtag include, then you type our stddef.h, then you close, then you hit enter. Then over here we can now create a comment. So **. So this is structure list int underscore s. This is singly linked list. Then we have our annotation. This is for integer. Then we have at next, which is for point to the next node. So description is singly linked list node structure. So right now, when you come over here, we are being asked to make use of this. Okay, this thing that I type over here, you can see that we have them over here. So instead of you typing, you can copy it and paste it over here. So you come here, then you copy this, come back to your terminal and paste. Then we can now include our function prototypes. So these are the function prototypes that we are making use of. So this is the first one. You copy, you come here, you paste. The next one is this. You copy, you come here, you paste. Next one is this. You copy, you come here, you paste. The next one is this. You copy, come here, paste. Then you come here, you copy, come back here, you paste. Then you move on to the next prototype. You copy, you hit enter, you come back here, you paste. Then you come over here, you copy, you come back here, you paste. So you come back here, you copy this, come back to the terminal and paste and hit enter. Come down here. So what we are doing is we are including all the function prototypes, okay, inside our header file, our list.h, so that we can now write the functions in our files. So you come back here, you copy this, come back to the terminal and paste, hit enter. You copy, come back here and paste, hit enter. You copy, come back here and paste and hit enter. You copy, come back here and paste and hit enter. You copy, come back here and paste and hit enter. So you come back here, you copy, come back here and paste and hit enter. Then the next thing that we are supposed to add is our put char. So int underscore put char into bracket car C. Then we can now end our this one. So this is just for lists. Lists underscore H. So when you are done, hit escape on your keyboard to enter the command mode. Then you type :WQ to save and quit. So right now when we ls, you can see that we have created our list.h successfully. So we can now push it to GitHub. So to do that, you type git add git commit -m created list.h. Then we now do git push to GitHub. So after creating our list.h, the next step is for us to now start with our task. So with task 0, we are being asked to write a function that prints all the elements of a list int underscore t list. Now this is the function prototype. And the function that we are supposed to create must return the number of nodes. So this is the format below. So this example that we see over here is what they are talking about. So we are allowed to use printf in this particular task. So to do that, we can now come back here, copy the name of the file, come back to our terminal and type vi and paste the name of the file and hit enter. So after clicking I on your keyboard, the next thing to do is for us to now type our code. So let's come back to the question. The question is saying that we are supposed to write a function that prints all the elements of a list int underscore list. So we have already included this prototype in our code already. So what does it do? It should return the number of nodes, and also we are supposed to see the example over here. Okay, and we are supposed to use printf, or we are allowed to use printf in our code. So the next thing that we are going to do is to include our list. So hashtag include our list .h file. Then we can now include our standard output and input. So hashtag include, then angle bracket stdio. That's our standard input and output file h. Then you hit enter. Then we can now put our comment over here. So the first thing is this print list int that we are creating. What does it do? It prints all the elements of a list int list. So print all the elements of a list int t list. So I'm just defining this over here for us. Then you hit enter. Then hit enter again. Then the @h that we have over here, what does it do? It's the head of linked list nodes. Then the next one, which is the return that we have over here, okay, what does it do? It returns the number of nodes. So when you are done, You just hit enter again and close your comment. Then you can hit enter. Then we can now come back here, copy our function prototype, come back to the terminal and paste. Then we can now hit enter and open our curly brace. Now the next thing that we are supposed to do is we are supposed to initialize count. So size underscore t count equals 0. Then so while into bracket our age, which is head of linked list, okay, if it's not equal to now, then this particular line of code should execute. So if it's not equal to 0, then print f. So we are printing the value. So we are printing the value. Then this is a new line. So that means we are looking at the next node h n. Then we can now terminate with semicolon. Hit enter. Then our h equals h next. That's the next node. Terminate with semicolon. Then we can now update our count. So count plus plus. So after this code is executed, okay, then we now return our count. So count. So we can now print the result of count on the screen. So whilst you are done typing your code, okay, so what this particular code is doing is that over here we have initialized count to 0. So our count is starting from 0. So we are saying that if the header, which is head of the linked list, is not now, then it should print the number. Then it will now be pointing to the next node. Then we have updated the count over here. So this will be executing until this is violated. Then it will display a count, or it will print all the elements of the list for us. So this, okay, assuming over here after checking for the first time, h is now pointing to 1. Then over here it will print the element located at 1. Then it will now move on to the next node. That is where the count plus plus will execute. Then it will come here, check the condition. Since it's moving on to the next node and it is not now, this code will execute. Then it will update. Then it will come back until this particular condition is violated. Then it will now display everything over here for us. So once you are done typing your code, hit escape on your keyboard and type :WQ to write and save, and hit enter. Then over here you can ls to see whether your file is there. You can see that our file has been created. So the next thing we are supposed to do is to create our main.c. Now remember, we are not pushing this main.c to GitHub, but we are using it to check our code. So the next thing that we are supposed to do is to create our main.c. So you can copy the whole of this up to here. Then come to this place and type vi 0-main.c. Then hit enter. In the command mode, hit I on the keyboard and paste. After pasting, hit escape, click on :WQ and hit enter.
So we can now test our code. But before that, let's use Betty to check our file. So Betty 0 dash print, then use the name of the file, then you hit enter. So after a successful check, we can now come down here and run this particular code. So after everything has run successfully, we can ls to see what we've got. So you can see that we have our a over here. So the next thing for us to do is to type :/a, then you hit enter. So you can see that we have 9 and 8, which is 2 elements. So we are having this same result. So that means our code is running successfully. So we can now add it to GitHub. So git add, then 0 dash print list. Then you now do git commit dash m, and my message is created task 0. And I can now do git push. After pushing this successfully, and if your checker is released, click on check code to check your code. So we can now move on to the next task. Over here we are listing the length. So we are being asked to write a function that returns the number of elements in a linked list. In a linked list int underscore t list. So this is the function prototype. So we will be writing this particular function in this task. To do that, the next thing that we are supposed to do is to come down here, copy the name of the file, come back to the terminal and type vi and paste the name of the file and hit enter. Then over here in the command mode, hit I on the keyboard to enter the insertion mode so that we can now type our code. Command mode, okay, let's now include our header file. So hashtag include our lists.h. Then you hit enter. Then over here we can now put our comment. So the list int, okay, the list int underscore t that we are creating, okay, what is it supposed to do? When you come over here, we are being asked that it's what? Write a function that returns what? The number of elements in a linked list. So I'll copy this, come back here and paste it. Then I'll hit enter. Hit enter again. So the h that we have over here, okay, this is just the head pointer. Then the return, what is it returning? It is returning the number of what elements. So return, okay, that is the number of elements. Then we can now close our comment. So what we are going to do is we'll come back here, copy the name of the file over here, the function prototype, come back to the terminal and paste, then hit enter, then type, you open your opening curly brace and your close curly brace, then we type our code. So right now we are also going to initialize our size t, our count, okay, to 0. So count equal to 0. Then we can now make use of our while statement over here. So while h, okay, which is our head pointer, is not equal to now, okay, then what are we supposed to do? So what we are supposed to do is h equals h next, then our count plus plus, then you terminate. Then when we come outside, we can now return our count. Now we are saying that, okay, we are supposed to write a function that returns the number of elements in a linked list. So this is going to return the number of elements. So if it's 10 elements, it will tell us 10 elements. If it is 8 elements, it will tell us 8 elements. So this is just basically going to tell us the number of elements. The first code that we wrote prints the elements, but this is telling us the number of elements. So once you are done typing the code, hit escape on your keyboard to enter the command mode and type :WQ and hit enter. Now in this phase, let's now use Betty to check our code. So you hit enter. After a successful check by Betty, so Betty is saying that no description found for function list int length. So it's saying that I have not placed any description over there for it. It's just a warning, it's not an error. So I can still go ahead and continue with my code. So that means Betty has run this particular file successfully, just that it came with a warning. So if you have a warning, you can still continue and execute your code. So the next thing that we are going to do is to create our main.c file, which we will use to test it. But mind you, please do not push your main.c file to your GitHub repository. So the next thing that we are going to do is to type vi and -main.c, then you hit enter. Then over here in the command mode, hit I on your keyboard to enter the insertion mode, then you paste your code. After pasting your code, hit escape on the keyboard, then you type :WQ, then you hit enter. Now the next thing that we are going to do is to run this particular command. So come here, copy the command, come back to the terminal and paste it and hit enter. So after a successful execution, we can now ls to see whether we have the file, which is the b over here. So we can now run ./b to see what the result that we get. So you can see over here we are getting 2 elements. So that means our function is working perfectly. So we can now add this particular file to our repository and push to GitHub. To do that, we'll now do git add one-list int length.c, then git commit-m, okay, created task 1, then git push. So that means we are done with task 2 also successfully. If your checker has been released, you can click here to click on check your code over here to check your code. Then you see that you will now have a green. So the next function that we are creating is a function that adds a new node at the beginning of a list int_t list. So the prototype that we added in our header file was this. So we are now coming to create this particular function. So now what does it return? It returns the address of the new element or null if it failed. So for us to be able to create this particular function or be able to work on this task, we will scroll to the bottom here, copy the name of the file, come back to the terminal. So let me clear the space so that the screen will be free for us so that you'll be able to see everything. Come back to the terminal and type vi and paste the name of the file that we copied from here, and you hit enter. In the command mode, you hit I on your keyboard to enter the insertion mode, then we can now type our code. So the first thing that we are going to do is so this is the function we are creating. So the first thing is for us to include our list.h that we created. So include lists.h and hit enter. Then we are also going to include our standard library header file. So include stdlib, so our standard library.h. Then you can now hit enter. Then over here we can now create our comment. So the add, okay, this particular add node int. So you come here, you copy this file or that name, come back here, paste it, and we say, what does it do? It adds new node. So you come here, you just copy this file, come back here and paste. Then the next one is our head. So head, what does it do? It's the head of double pointer. So head of double pointer. Then the next one is our n, and what is it? Is int what? Add the list. So int add the list. Then we now have our return. Okay, what is it returning? It is returning now if it failed. So when you are done, you can now close your comment and we can now start with our function. To do that, come back here and copy your function prototype, because we'll be using it as a function header. So without the semicolon, it becomes a function header. So you paste it over here, hit enter, then you now type your opening curly brace and closing curly brace, then we type our code inside. So what we are going to do is we are going to list int underscore t, okay, pointer ptr. Then we are saying that if, okay, the head, which is head of the double pointer, okay, is equal to null, okay, what should happen? It should return null. So we are saying that if, okay, if it fails, it should return null. That means if the head is equal to null, it is going to return null. Now our ptr, okay, equal to malloc memory allocation size of list int underscore t. Then if ptr, okay, our pointer is equal to null, what should happen? Should return null. So ptr, so ptr point to n, tr point to n, okay, is equal to n. Then ptr next, okay, is equal to head. Then our head will now be equal to ptr. So after this, we can now return our PTR. So return PTR. So what this particular code is doing is we are writing a function, okay, that has a new node at the beginning of the list int. So if the head, okay, is null, then it's going to return null. And if it is not that, then PTR will now do memory allocation, that's size of the list int. Now if the pointer, which is PTR, is null, then it is also going to return null. Otherwise, PTR maps to n. PTR maps to n will now be equal to n. So if you are done typing the code as we have over here, hit escape on your keyboard to enter the command mode. So escape to enter the command mode. Then you type :WQ to save and quit. So you now type :WQ to save and quit. So you are saving and returning back to the previous page. When we ls, you can see that we have our file that we created over here, which is 2 add node int.c. So when we are done typing our file, our code, okay, we need to test it with Betty. So type Betty, then the name of the file, then you hit enter. So after a successful execution by Betty, okay, we can now create this particular main.c to test our code. But please do not push this to GitHub. To do that, come back to your terminal after copying this particular code. After copying this particular code, come back to the terminal and type vi main 2-main.c. Then you hit enter. Then over here, click I on your keyboard and type, or then you paste it. After pasting, hit escape on your keyboard and you type :WQ. Then you hit enter. After doing that, you can now come back to this place and copy this particular code and run. So after copying the code, let's come back to the terminal, paste the code and hit enter. So after a successful execution, when we ls, you can see a green C file over here. So to run it, you type ./ then C, then you hit enter. So when you look at the result that we have over here, and the result that is over here, you can see that we have the same result. So in this way, our code is running successfully. If your checker has been released, just click on check code, then you are good to go. Please, for you not to have a plagiarized work, or for you not to have a copy work, make sure you change the variables. So the places where you see that I'm using A as my variable, you can use B or C or D as your variable, and still your code will run successfully. So the next task is add node at the end. So we are being asked to write a function that adds a new node at the end of a list int t-list. So now this was the prototype that we added into, or we included in our list.h. Then they return the address of the new element or null if it failed. So for us to perform this particular task, come down here, copy the name of the file, come back to your terminal and type vi and paste the name of the file and hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then we can now type our code. So in the insertion mode, we can now first of all include our header file, which is list dot h, then include our standard library, so stdlib dot h, then hit enter. Then we can now write our comment. So add node int end. Okay, what does it do? It just adds node at the end of this t file. Then we have our head over here. What does it do? Is the head of double pointer. So I can see that my off has been changed to odd. So let me just make it off. Then we move on. Then you hit enter. Then we can now our n. Okay. What is it? Int add the list. Then the last one is return. And what is it returning? Now if it failed. So when you are done with this, close your comment, hit enter. Then we can now come back to this particular place, copy only the function header without the semicolon, come back and paste, hit enter and type your or open your curly brace. Then we can now type our code inside. So first of all, list int underscore t is having a new pointer. Then we have our list int underscore t, then temporal temp. So we are saying that now if head equals to now should return now. New equal to malloc size of list int underscore t. Now we are saying if okay the new is equal to now, then return now, else new will point to n, which is equal to n. Then new next okay will now be equal to now, because we are saying we are adding it at the end of the list. So when you add something at the end, it will now be pointing to nothing now. If you want it to point to the next thing, because it's the last thing over there. So that is why we have new next equal to now. Now if head, okay, our head pointer is equal to now, okay, then this particular code will execute. So that is head pointer equal to new, then return new. Now tmp equal to head, while our TMP next is not equal to now. Then TMP equal to temp next. Then temp next will now be equal to new. Then we now return new. So this is the function that is adding new node at the end of list int t list. Okay, so we are saying that if the head is equal to now, then it should return now. Otherwise, there should be new memory allocation with the size of list int t. Now, if new over here, okay, is equal to now, then it should return now. Otherwise, the n, okay, the int, the list, okay, new n will now be equal to new. It will now be equal to n. And the new next will now be pointing to now. So okay, so this n is the list that will be added at the end of the list int. Okay, so now when you are now the last person at the end of the list, if they ask you to point to the next person, there is no next person, so you'll be pointing to now. That is why we have this over here. Now this statement is also saying that if head pointer is equal to now, then head pointer will now be equal to new. So we will now return new. Now temp is equal to head pointer. So while temp next is not equal to now, then temp is equal to temp next. Therefore temp next is equal to new. Then we are returning new. So whilst you are done writing this function, hit escape on your keyboard, then you type colon WQ, then you hit enter. And we can now use Betty to check our file. After a successful check by Betty, we can now come back here, copy this particular file and use it to run our code. So come back to your terminal and type vi 3-main.c and hit enter. Then you type I on your keyboard to enter the insertion mode, then you paste this particular example file. Then click escape on your keyboard, then you type colon WQ, then you hit enter. Now the next thing that we are going to do is we are now coming here, copy this code and execute. After a successful execution, when we ls, we can now see a D file, which is this. So the next thing we are going to do is ./d and hit enter. So you can see that this particular result is similar to the one we have over here. So that means our function is running successfully. So we can now add our 3add node int end.c to our repository and push to GitHub. So to do that, we type git add 3-add, then git commit -n, then you type created task 3, then git push. So after a successful push to GitHub, you can click on the checker if your checker is released to check your code. So the next thing is for us to move on to task 4. So to do that, we are being asked to write a function that frees a list in t list. So the prototype that we included was the void free list int prototype. So to do that, come down here, copy the name of the file, come to your terminal and type vi and paste the name of the file and hit enter. In the command mode of your vi, click I to enter the insertion mode. then we can now type our code. So the next thing that we are going to do is to include our list.h file. Then we also include our standard library.h. Then we can now state our comment, or we can now write our comment. So I'm going to copy this particular text over here, come back here, hit enter and paste. So what does this do? It frees this. Then what is our head doing over here? This is the head of the list. Then the next one is return. What are we returning? Now if error. So after typing your comment, we can now come here, copy the function header, come back to the terminal and paste and hit enter. And now open our opening and closing curly brace. Then we can now type list int underscore t. Okay, we'll now be pointing to our pointer next. Then while head, okay, it's not equal to now. It's not equal to now. Then next equal to head next. And also free. Okay, we can now free our head. Then head will now be equal to next. When you are done with this, okay, hit escape on your keyboard, then type :WQ to save and quit. Now in your terminal, let's check our code with Betty. So to do that, you type Betty, then /, and hit enter. So after a successful execution by Betty, we can now run our code. But before we do that, we have to come here, copy this particular file. Okay, come back to our terminal and type vi -main.c and hit enter. After that, hit I on your keyboard to paste your code. After pasting, hit escape on your keyboard and type :WQ and hit enter. Then after doing all of this, come back here and copy this particular code. Come back to your terminal, paste it and hit enter. So after a successful execution, let's ls to see whether we have an e file over here. So to run this, you type ./e and hit enter. So you can see that we have this as a result. So you can see that we have this as a result. So that means our code is running successful. So we can now add this to our repository. So git add, then /free, then git commit-m created tags 4, then git push. If your checker is released, you can now check your code. So the next task that we are going to work on is write a function that frees a list int list. So the prototype that we included is the void free list2 int. Then the function set the head to null. So to do that, you come down here, copy the name of the file, come back to your terminal and type vi and paste the name of the file. Hit I on your keyboard to enter the insertion mode. Then we can type our code. Now this is our code. Okay, we have included our list.h, then includes standard library.h. Then over here, this is the function that we are creating. Now we are saying if the head is equal to null, then it should return. While head, pointer head is not equal to null, then next is equal to head next, free head, then head next. So whilst you are done typing your code, hit escape on your keyboard and type :wq in the command mode and hit enter. Then over here we can use Betty to check our code. After a successful execution by Betty, we can now create our main.c and use it to run our code. So come here and copy the whole of this. Come back to the terminal, type vi 5-main.c and hit enter. Hit I on your keyboard and paste your code. After pasting your code, hit escape on your keyboard and type :wq and hit enter. Now after doing all this, we can now come down here, copy this code and execute. After a successful execution, when we ls, we will see an f file. So to run this f file, you type ./ and f, then you hit enter. So you can see that this particular code has been executed successfully. So after a successful execution, we can now push it to GitHub and check our code. To do that, you do git add, then 5-free list, then git commit -m created tags 5. Then we can now do git push to GitHub. Then when your checker is released, you click on check code to check your code. Now the next task is task 6. We are being asked to write a function that deletes the head node of a list int t linked list and returns the head node data n. So the prototype that we included in our header file, which is list.h, is this particular function prototype. So we'll be writing this function in this task. Now we are also being told that if the linked list is empty, then we are supposed to return 0. So to do this, come down here, copy the name of the file, come back to your terminal and type vi and paste the name of the file and hit enter. In the command mode, hit I on your keyboard to enter the insertion mode, then we type our code. Now in our code, you can see that we have included our header file that we created, our standard library, and also this is the function that we are creating. Now we are saying that, okay, if the function should delete the head of a node and returns the head's node data, and also if the linked list is empty, we are supposed to return 0. So that's why you see if head is equal to null or head pointer is equal to null, then we are supposed to return 0. That means if our linked list is 0, we should return 0. Otherwise, we should delete the head node of the linked list and return the data. That's why we are returning our n over here. So after typing your code, hit escape on your keyboard, then type :wq and hit enter. And we can now use Betty to check our code. After a successful check by Betty, now we need to run our code. So to do that, come down here and copy this particular example main.c file. Come back to the terminal and type vi 6-main.c and hit enter. In the command mode, hit I to enter the insertion mode and paste the code. After pasting, hit escape on your keyboard, then you type :WQ and hit enter. Then the next thing that we are going to do is to come down here and copy this particular code and run it in the terminal. After running the code and successfully, when we ls, you can see that we have a G file. So we can now run it. So to do that, we do ./G and hit enter. So you can see that our code, which is the example that we see over here, has been run successfully. So after a successful run, you type git add, then the name of the file 6-pop, then git commit-m created task 6, then git push. If your checker has been released, you click on check code to check your code successfully. The next task that we are going to do is the get node at index. So the function prototype that we included in our header file was this. Now we are being asked to write a function that returns the nth node of a linked list. Now where index is the index of the node starting at 0. Now if the node does not exist, then we should return null. So in this particular task, we are going to write this particular function, and it must satisfy the whole of this requirement that is here. So to do that, we come down here, copy the name of the file, come back to your terminal and type vi, and you paste the name of the file and hit enter. In the command mode, hit I to enter the insertion mode so that we can type our code. After typing our code, we included our list.h. Then this is the function that we've written. What is this function doing? Now this function, is returning the nth node of a list. So the index, the index we have over here is the index of the node starting at 0. So this particular index that you can see as the function parameter. So after we are done typing our function, hit escape on your keyboard. Hit escape on your keyboard to enter the command mode. Then we type :WQ. Then you hit enter. Then over here, the next thing that we are going to do now is to first of all use Betty to check our code. After a successful check by Betty, we can now come here, create our main.c file and use it to check to run our code. So come back here and type vi 7-main.c, then you hit enter. In the command mode, hit I to enter the insertion mode, then you paste your code. Then over here, after pasting your code, hit escape, then you type :WQ. After doing all this, then we come back, copy this code, go back to your terminal and paste it and hit enter. After a successful execution and when we ls, we can see an H file over here. So to run this particular H file, you do ./h and you hit enter. So you can see that we are getting this same result. That means our code is running successfully. So we can now push it to GitHub and check our code. So to do that, you do git add 7-get, then git commit-m created task 7, then git push. After pushing to GitHub, can come here and check your code. After a successful check of your code, we can now move on to task 8. Now we are being asked in task 8 to write a function that returns the sum of all the data n of a linked list T. So the prototype that we included in our header file was this particular file. So we are going to write this particular function. Now if the list is empty, we are being asked to return 0. So to do that, come down here, copy this particular file, come back to your terminal and type vi and paste the file and hit enter. Now in the command mode, hit I on your keyboard to enter the insertion mode. And let's type our code. So our code over here, okay, we are being asked to write a function that returns the sum of all the data of the linked list. So you can see that over here we are making our iterated summation over here. So after the first sum, it will now point to the next item, it will add it, it will point to the next item, it will add. Then at the end, it will return our sum. Now the reason why we initialize sum to be equal to 0 is that so that if the list is empty, we can now display our 0. So after you are done typing your code, hit escape on your keyboard to enter the command mode, and type :WQ and hit enter. Then over here we can now use Betty to check our code. After a successful check by Betty, we can now come here, copy this particular main.c file and use it to run our code. So to do that, you type vi8-main.c, then you hit enter. After that, hit I on your keyboard to enter the insertion mode, then you paste the code. Then hit escape and type :WQ and go back to the previous page. After this, come back to this place, copy this particular script, paste it back in your terminal and hit enter. After a successful execution of ls, we will see an I file over here. So we can now run it by typing ./i. So you can see that we have our sum, which is equal to 1534 that we have over here. So that means our code is running successfully. So we can now push this to GitHub and check our code. So to do that, you do git add 8-sum, then git commit-m created task 8, then git push. After pushing to GitHub, we can now click on check our code, and after a successful check, okay, so the next task is our task 9. We are being asked to write a function that inserts a node at a given position. So to perform this particular task, come down here, copy the name of the file, come back to your terminal and type vi and paste it. In the command mode, hit I to enter the insertion mode, then we can now type our code. Now this is the function we are being asked to write. Okay, as you can see, we have included our list.h header file that we created, and also we have included our standard library. Now this is our function name, and also these are our function parameters. Now we are being told that we should write a function that inserts a new node at a given position. So we are also being told that, okay, if it is not possible to add a new node at the index IDX, then we should not add a new node, but rather we should return null. That is why we are having something like this, and also this over here. So when you look at the whole of this code, you can see that it has satisfied the whole of this statement that we have over here.
Then the next thing that we are going to do, okay, is to now click escape on your keyboard, then you type :WQ and hit enter. Then we can now use Betty to check our code. After a successful check by Sister Betty, you can now run your code. But before we do that, we need to copy this particular main.c file and use it to run the code. So copy this file, come back to your terminal and type vi 9-main.c and hit enter. In the command mode, hit I on your keyboard to enter the insertion mode. Then you can now paste your code. After pasting the code, type escape and type :WQ. Then from here, we can now type this particular code. So come here, copy this particular script, come back to your terminal, paste it and hit enter. After a successful execution, when we ls, you can see that we have a file called J over here. So to run J, we type ./ then J and hit enter. So you can see that our file has executed successfully and we are having the same result. So this means our file has executed successfully. So we can now add this to our GitHub repository. Then we can now commit created task 9, then git push. After pushing to GitHub and your checker has been released, you can now click on check code to check your code. Then from there we can now move on to task 10. Now what is task 10 telling us? We are being asked to delete at index. So write a function that deletes the node at index of a linked list. Now the prototype that we included in our list.h is this particular prototype. So we are going to write this particular function in this task, where index is the index of the node that should be deleted. The index starts at 0. Now we are supposed to return 1 if it is successful or -1 if it failed. So to do that, we will come down here to the bottom here, copy this particular file name, come back to our terminal and type vi and paste the name of the file and hit enter. In the command mode, hit I to enter the insertion mode. Now we have included our header files. Okay, now when we come to our function, we are saying that if it is null, okay, if the content is null, then what happens? It should return -1. But if the index is equal to 0, then it should now find the next file, then it should now delete the first one. Now it will now assign the next file that it has found to as the first one, then it will now return 1. Now this is a for loop, so it will iterate and do this until this particular condition is violated. Then it can now return our result. So after you are done typing the code, hit escape on your keyboard, then you type :WQ, then you hit enter. Then over here we can now use Betty to check our code. After a successful check by Betty, okay, we can now come here, copy this particular file and use it to run our code. So come here and copy this particular main.c file up to here. Come back to your terminal and type vi 10-main.c and you hit enter. In the command mode, hit I and paste your code. Then hit escape and type :WQ and hit enter. Then from here, we can now come here and copy this particular script Come back to your terminal and run it. So after a successful execution, okay, when we ls, we will see a file called k. So we can now do ./k and run it. So when you look at the result that we've gotten and this particular result, you can see that we've gotten the same result. So in this way, our code has run successfully. So we can now add it to the repository and push it to GitHub. So to do that, we will do git add 10-delete git commit -m created tags 10, then git push. Now if your checker has been released, you now click on check code to check your code. Then we can now move on to task 11. Task 11 is saying that we should write a function that reverses a list int linked list. So the prototype that we included in our header file is this particular prototype. Now it's supposed to return a pointer to the first node of the reversed list. We are not allowed to use more than one loop, and also we are not allowed to use malloc, free, or arrays. You can only declare a maximum of 2 variables in your function. So to do this particular task, okay, let's come down here and copy this particular file 100 reverse list in.c. Come back to your terminal and type vi and paste the name of the file that you copied. Hit I on your keyboard to enter the insertion mode. Then we can now type our code. So we included our list.h over here. Then we are saying that if the list is empty, then it should return null. Otherwise, if it is not, it will pick the head next. So if the head pointer or the next is null, then it should return the head. So previous is equal to null. So over here we are saying that, okay, so a pointer to the first node of the reversed list. So that is why we are returning this particular thing. So over here, this particular function is reversing the linked list. So after you are done typing, hit escape on your keyboard and type :WQ and hit enter. After that, we use Betty to check our code. Now, it is not advisable for you to type the same codes, otherwise it will be plagiarism. So you can look at my code, then you write your own. I just want you to understand whatever you are doing, the functions that you are writing, you understand it. And also, if you want to use my code in a similar way, then you have to change the variables so that you won't have a plagiarism over your heads. So after successful run by Betty, the next thing that we are going to do is to come here and copy this main.c file. Come back to the terminal and type vi 100-main.c and hit enter. Hit I on your keyboard to enter the insertion mode and paste your code. After that, hit escape and type :WQ. After creating your 100-main.c, come back here and copy this particular script and back to your terminal and paste it and hit enter. After a successful execution, let's ls and see our result. So you can see that we have this particular I file over here. So this particular L file over here. So to run the L file, you can now do ./L and hit enter. So you can see that we are having similar results over here. That means our code has executed successfully. So we can now add it to our repository and push it to GitHub. To do that, you type git add 100- reverse list in.c. Then you type git commit -n created tax 100. Then you now do git push. After a successful push to GitHub, you can now click over here to check your code. Then we can now move on to the next task. So over here, we are being asked to print safe version. So we are being asked to write a function that prints a linked list. The prototype that we included in our header file was the size t print list, this particular prototype. So what does it return? It returns the number of nodes in the list. This function can print list with a loop, and also you should go through the list only once. If the function fails, exit the program with status 98. So we are supposed to have this particular format. So to create this particular code, or for us to do this particular task, come down here and copy the name of the file. Come back to your terminal and type vi and paste it. In the command mode, hit I to enter the insertion mode. Then we can now type our code. So after typing our code, we will click on escape and type :wq. Hello. So after typing our code, okay, the condition is that it should return the number of nodes in the list. And also this function can print list with a loop. So when you come over here, okay, we are having this particular function. Then you can see that we have our second function over here. Now this function prints a list t in a linked list. So when you are done typing your code, click escape on your keyboard, then you type :wq and hit enter. Then over here we can now use Betty to check our code. After a successful check by Betty, we can now come down here and copy this particular main.c file. Come back to the terminal and type vi 101-main.c and hit enter. Then in the command mode, hit I and paste your code. After pasting, hit escape on your keyboard, then type :wq. After doing this, come back and copy this particular script and run it in your terminal. After a successful execution, when we ls, we can see an M file created over here. So to run this particular file, you do :/m, then hit enter. So you can see that we are having similar results over here. That means our code is running successfully. So we can now push it to GitHub. To do that, type git add 101-print and do git commit -n created advanced tax 2. And you now do git push. After a successful push to GitHub and your checker has been released, you can now click on check your code. So after that, we can now move on to the next task, which is task 13, free safe version. You are being asked to write a function that frees a list int t list, prototype size t free list int _save. This function can free list with a loop. You should go through the list only once, and also it returns the size of the list that was freed. The function sets the head to null. So to create this particular function, come back to the down here and copy this particular file name. Come back to your terminal and type vi and paste the name of the file that you copied. In the command mode, hit I to enter the insertion mode so that we can type our code. After typing your code, hit escape on the keyboard, then type :WQ to save and quit and go back to the previous page. So we can now use Betty to check our code. After a successful check by Betty, we can now create our main.c file and use it to check our code. So to do that, you come here to copy the examples given. Come back to the terminal and type vi102-main.c and hit enter. In the command mode, hit I to enter the insertion mode and paste your code. After pasting the code, hit escape to enter the command mode and type :WQ. After that, come back here and copy this particular script. Come back to your terminal, paste it and hit enter. After a successful execution, when we ls, we will see an end file over here. To run this file, you type ./n and hit enter. So you can see that we are getting the same result as this. So that means our code is running successfully. So we can now push it to GitHub. To do this, we need to do git add 102-free, then git commit-n created advanced tax 3, then git push. Then we can now move on to the final task of today's project. That is find the loop. Now we are being asked to write a function that finds the loop in a linked list. So the prototype that we have included in our header file for this particular task is this particular prototype. So this is the function that we'll be writing in this task. So what does it do? It returns the address of the node where the loop starts, or null if there is no loop. We are not allowed to use malloc or free or arrays. We can only declare a maximum of 2 variables in our function. So the function finds the loop in a linked list. So to write this particular function, come down here and copy the name of the file, which is 103-find loop. Come back to your terminal and type vi and paste the name of the file and hit enter. In the command mode, hit I to enter the insertion mode, then we type our code. Now, after typing our code, okay, you can see that we have included our list.h over here. Then we have our variable. So my variable is tortoise and hare. Okay. Now what am I doing? Over here, what I am doing is I am writing a function that finds the loop in a linked list. So it returns the address of the node where the loop starts, or now if there is no loop. So over here, if there is no loop, you can see that it is returning now. But if there is a loop, then it is returning the address. That is why you are seeing this particular if and while loops that we have over here. So the reason why I only have 2 variables is that I'm being told that I can declare only a maximum of 2 variables. After typing your code, hit escape on your keyboard to enter the insertion mode, then type :WQ and hit enter. Then we can now use Sister Betty to check our code. After a successful check by Betty, we can now create our main.c file and use it to run our code. So to do that, you come here, you copy this particular main.c file. Go back to your terminal and type 103 main.c and hit enter. So you come back to the terminal, you type vi 103-main.c and hit enter. Then hit I on your keyboard to enter the insertion mode and paste the code. After that, hit escape and type :wq and hit enter. So to run this particular file, we can now come here and copy this script. Come back to the terminal, paste it and hit enter. After a successful execution, let's do ls to find our file. So you can see that we have a file called o over here. To run it, you type ./o and run. You can see that our answer and the answer that we have over here are the same and similar. So that means our code has run successfully. So to add this particular code to our repository, you do git add, then the name of the file 103 find, then we now do git commit -n created advanced tags 4, then you do git push. After a successful push to GitHub, you can now come over here. If your checker is released, then you click on check your code. If you are a returning subscriber, thank you for your loyalty and thank you for returning back to my channel. If today is your first time visiting my channel, please hit the subscribe button and also the notification icon so that anytime I have a tutorial, you'll be the first to get notified so that we all grow together. Please, to prevent plagiarism, please, you can change the variables. So declare your own variables. The variables should not have the same name as my variables so that all of us will grow together. Thank you.